So let's say you need to find the distance between these 2 points. Normally how we do that is we just count 1, 2, 3. And so the distance between these 2 points we would say is 3. Okay? One other way we could find the distance between 2 points is if they're horizontal from each other, like this. So again, I could count 1, 2, 3. But what if those points look something like this? So right here, my grid marks don't help me count. So how are we going to count these? Well, in order to do it, what we're going to do is we're going to start thinking about this like a triangle. So if I draw a line straight this way and then a line straight up, you can kind of see how our distance between these 2 points is actually going to be the same distance as the hypotenuse. I'm going to label that there. The hypotenuse of a right triangle that has the same points as its vertices. So how does that help us? Well, if I think about a right triangle, it gets me to a very common thing we use with right triangles, and that's called the Pythagorean Theorem. And what the Pythagorean Theorem says is if I take one of the legs, remember what we mean by leg is the 2 sides that are, adjacent to each other and connected to the 90-degree angle. So here's leg number 1, here's leg number 2. So if I take leg number 1 squared and then I take leg number 2 squared, what that always is going to equal is the hypotenuse squared. And I'm just going to label it HYP. Now, how is that helpful? Because if I think about this as a triangle, I can now get an understanding for the lengths of both sides of these triangles by considering the coordinates at these points. And if I think about the coordinate at this point, what is going to be the length of this triangle? Well, we know that the x-coordinate at this point is going to be whatever it is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the same thing down here. My x-coordinate is just 1, 2. So I have an x-coordinate of 2 here, an x-coordinate of 10 here. So how we find the length of these sides is we just simply subtract 10 from 2, right? 10 minus 2 gets me 8, which is the length of this entire side. And then same thing up here. We have another side, and I'm going to do this in a different color. Let's do it in green, where I can now consider the y values of both of these points, and they're going to end up here on the y-axis. So my y value of this point is going to be 2. My y value, 2, 3, 4, 5, 6 is for this point. And now how do I find the length of this side over here? Well, it's by subtracting my y values. So it'd be 6 minus 2, which is 4. So now that we know that this side is 8 and this side is 4, we could use the Pythagorean theorem to solve for the length of the hypotenuse. We would just have to do a 4 squared plus 8 squared equals hypotenuse squared, and we could solve for it. But let's just generalize this a little bit. In order to find the length of one of the legs, what did I have to do? So if I have a coordinate and let's say it's labeled x1, y1, and another coordinate that's labeled x2, y2, this is just an arbitrary coordinate. What I did is I took their x values, so x2, and I subtracted it from x1. That's what I did down here, right? I took my 10 and I subtracted it by 2 to get 8 as one of the lengths of the legs. And then the same thing goes here. I'm going to add the other length of the other leg, which is going to be just whatever the y-coordinate of the second point minus the y-coordinate of the first point. So I would label it like this, y2 minus y1. And then that's going to be equal to whatever the hypotenuse squared is. And so instead of labeling it as the hypotenuse squared, I'm just going to label it as D for distance, because this is going to be the hypotenuse of this triangle, which is essentially the distance between these 2 points. So now that I know this, how do I know what the distance is between these 2 points? Well, if I know what distance squared is, we'd say distance squared is this equation right here. Well, in order to find what the distance is, if that's what distance squared is I need to take the square root of both sides in order to get d by itself. So if I take the square root of both sides, what I'm going to get as my equation is d, because the square root and the squared cancel, d equals the square root of this entire equation right here, which is x2 minus x1, the second coordinate of x minus the first coordinate of x, plus the second y coordinate minus the first y coordinate squared. So now, if I've been given 2 points, I'm going to label those 2 arbitrary points like this, x1, y1, and x2, y2. I can say that my distance between those 2 points can be found like this.